Alright, so let's talk about simplifying radicals here. Remember, radicals are things that have a square root in them. So if we're talking about a radical, we're talking about something like a square root. And we can generalize from the square root idea to a cube root of something or to a fourth root of something as well. But if we study the rules for square roots, we can generalize all those rules to the third roots and fourth roots and things like that. We're going to talk today about multiplication, the multiplication property of roots and radicals, and maybe get to simplifying radicals and then using that multiplication property. But basically the multiplication property of radicals says that whatever's inside that radical sign, here's our radical sign, or the house of radical, a radical house, can be rewritten into its factors. Remember, factors multiply together to get a product. So here's our product, AB. And our product AB can be rewritten as the product A, the factor A times the factor B. And in general, this nth root is going to stay as a square root, but it can generalize into third roots and fourth roots and things like that. So here's what we're going to try and do. We're going to rewrite square root of 100, and we're going to say that a square root of 100, what is that? Square root of 100, we know. We're going to take a shortcut over here. What's the square root of 100? It's 10. We know that, but I'm going to show you that what we can do here is kind of break this apart, this 100, into two other things and get the same product. Well, square root of 100 is what? Well, according to the multiplication property of radicals, we can kind of break it apart and say 100 is 25 times 4. All right, sounds good. And all I did was rewrite 100 as 25 times 4. Now, using this multiplication property, I'm going to take 25 and give it its own house. Remember, these guys have roofs over their house. Roofs over their house. Smart doesn't do a good job with the square root symbol. But from here to here, all I'm doing is separating and conquering, really. 25 gets its own house, 4 gets its own house. Now, what's the square root of 25? Square root of 25 is 5. Square root of 4 is 2. And 5 times 2 gives us 10. So what I'm doing is showing, kind of taking, number one, saying, what's the square root of 100? We know it's 10. Well, we're going to use this property here to show you that we can use this property to kind of separate and conquer. And if we can separate and conquer, we can make something in here that's not square root of 100. Square root of 100 is just too easy. But this is just an example to show us that we can separate and conquer. And keep in mind too, so we're gonna use the idea of separating and conquering to make things simpler with different products or different different products inside here. Later on, we're going to find that this actually goes both directions. So we can take this and separate and conquer, or later on, we might be able to take these and combine and conquer. So let's take this multiplication property of radicals right here, this whole idea that we can separate and conquer using radicals, and maybe apply it to a couple different examples. Before we get going, though, we should probably talk about some terminology. Here's the index. In general, that's going to be usually 2, and usually an unwritten 2. There's our index, and there's our radicand. So whatever's inside the house, and I call this is the radical sign, or the radical. I call it the house of radical, or sometimes the house. Radicand is what's inside. Here's our index. So there's just some terminology there to go on. Index is the 2 usually. And we're going to need to separate into perfect squares and not perfect squares. So back over here, we got 100. We knew 100 was a perfect square. But we could separate that 100 into, and if this were not a perfect square, what we would try to do is separate into a perfect square times whatever else this is. I know that 100, if I took a look at 100, well, let's see. What are my perfect squares? 4 is a perfect square, so does 4 go to 100? Yes. Let's rewrite it as 4 times whatever's left over, and it just happens that whatever's left over, that 25, is a perfect square also, but that's what we try to do. Rewrite it as a perfect square times something else, and then that perfect square gives us something that comes out of the house. Just so happens that that 25 also has something that comes out of the house. So let's take a look at something like that and using that idea. But before we use that idea, we need to really kind of look at perfect squares. What are perfect squares? Well, all these numbers over here are perfect squares because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. All these guys are the perfect squares, and we're going to try and rewrite whatever's inside of our house in terms of one of these numbers times something else. We'll get to this in just a second, but right now we're going to concentrate on just these numbers, and by the way, these go on just like Buzz Lightyear to infinity and beyond. So keep those perfect square numbers in mind. Some tricky ones are going to be like 121 is 11 squared. 225 is 15 squared, something like that. So keep those in mind as well. But all those perfect squares are things that we should know. All these in the rectangle right here, in the blue rectangle, we need to know those. And those are a need to know because what we're going to try and do is simplify these guys right here using pretty much these rules here. In order to simplify a radical, we need to pull out perfect squares. What are perfect squares? Well, right here, no radicals in the denominator. Oops. We'll look at that later on. But really, no factor in the radicand inside the house has a power that's greater than or equal to the index. So if we've got something like a unwritten square root of 4, well, we could rewrite that as square root of 2 squared. Well, here's a base squared. This 2 can't be bigger than that. And with numbers, we don't have to really worry too much about that right now. But right now, we kind of rewrite this 4 as a 2 squared. So we can say then that this violates rule number 1 because this factor here has a power that's equal to or greater than this. So that means that that 2 can come out of the house. This 2 here can come out of the house. So that's what we have to avoid. Anything, any factor in here that has a power that's greater than or equal to this. So let's go down here and kind of take a look at this. Well, square root of 4, what's 4? Square root of 4, well, we know it's 2. But I'm going to recommend that we kind of write things as, if this is a perfect square, write it as a base squared, because we're taking a look at square roots of it. Remember up here, we're taking a look at the square. Can't be bigger than this index here. So square root of a perfect square means that that base comes outside the house. We're going to try and rewrite whatever's inside this house as perfect squares times something else. And then rewrite it as a base squared. So let's take a look at square root of 9. We know it's 3. Square root of 9, that's 3. But I'm going to rewrite that as a perfect square times something else, and then, which it is already, and then rewrite it as a base squared. So that when we take the square root of a perfect square, the base comes outside the house. And we're going to use this idea, rewriting in terms of a perfect square times something else, and then rewriting that perfect square as a base squared. How about over here? I got a square root of 8. Let's see, is 8 a perfect square? No, it's not. If we look back at our perfect square list, it's not on there. That's not on there. So we have to maybe rewrite that 8 as a perfect square times something else. Okay, well, let's see. I've got the perfect squares are 1 squared is 1, 2 squared is 4. 4 times, does 4 go into 8 evenly? Yeah, it does. All right, so I'm going to rewrite that 8 as 4 times 2, and that's my first thought. Rewrite that 8 as a perfect square times whatever's left over. 4 times 2 is 8. 4 is a perfect square. Now use the multiplication property of radicals to say that each one of these factors gets its own house. Square root of 4 we know already is 2, so I'm going to put that down as 2. And remember, these are all multiplied together. This is multiplication, this is multiplication. Down here is multiplication as well. I got 2 times the square root of 2. Square root of 4 is 2, and we can go the long way over here if we need to. Rewrite this perfect square as a base squared, and then the base comes outside the house, or square root of 4, I just know it's 2, and now we're just multiplying as well. And there's our answer, is 2 square root of 2 is our answer. Square root of 8 simplifies to 2 square root of 2. Square root of 18. All right, let's see, is square root of 18, is 18 a perfect square? It's not. All right, rewrite it as a perfect square times something else. Square root of, let's see, 18 is, let's see, perfect squares are 1. It doesn't help us. 4 times something. Does 4 go into 18? No. Does, what's the next one? 3 squared is 9. Does 9 go into 18? Yeah. We can rewrite it as 9 times 2. Square root of 9 gets its own house. Square root of 2 gets its own house using the property of multiplication property of radicals. Square root of 9 is, we can go the long way over here, but we can also say that that's just 3 outside the house times square root of 2. And done. Over here, square root of 72. Wow, okay, well, you know what? I'm going to, yeah, let's see. Square root of 72, does 4, my first thought is, does 4, my first perfect square, does 4 go into 72? 4 into 72, yes it does. It's, let's see, square root of 4 times 72 divided by 4. is 18. Square root of 4 gets its own house. Square root of 18 gets its own house. I got 2 square root of 18. And I think I should be done, but wait a second. Darn it, we just did square root of 18. Square root of 18 is square root of 9. So anytime we factor this out, we have to look at 18 and say, well, does 18 have something else that can be pulled out? So I've got 2. I'm going to extend my page here to get some space. I got 2 square root of 9 times 2, 2 times square root of 9 times square root of 2. Remember, this is all multiplication. These are all multiplied together. I got 2 times 3. Square root of 9 is 3. Square root of 2 stays as square root of 2 because it stays inside the house. 2 comes out, and this is where columns help a lot. You can kind of track where everything goes here by following whatever columns you've got here. So make sure you keep the columns straight, and it'll be a lot easier to double check all your work. But now here we're almost done because outside the house, and I call this inside the house, outside the house. Outside the house, I got 2 times 3, and everything's still multiplied together. So my answer is 6 times the square root of 2, and I'm done. Because the square root of 2 has come outside the house, the square root of 9 came outside the house, the square root of 4 came outside the square root of 72 house, and we just separate and conquer. There's our answer.